Welcome to my booth. It's all about virtual commissioning for our engineering customers. We want to show them how to reduce their time to market by moving virtual commissioning from the shop floor to the office environment and carrying out their work on the digital twin. What is a digital machine twin? It consists of 3 parts. On the left side, you see our digital twin of Sinemeric 1. A fully fledged control twin is depicted with a drive model, control model, and an NC core, with HMI and a machine control panel as a fully operable element of the control. In order to be able to carry out our virtual commissioning afterwards and to get feedback from the field accordingly, we of course need a counterpart to our control. You can see on the right-hand screen, that's the next component of our digital twin, our virtual behavioral model. The behavior of all components in the machine is mapped. The control cabinet components, the components inside the machine, such as hydraulic pumps, pneumatic units, cylinders, valves, and so on. Here, the counterpart of the controller is mapped and signals can be generated. In addition, we can interact with our control model via switches. That means the developer has the ability to test its commissioning process, test emergencies, and perform certain aggregate failures. They can test whether the right signals are issued at the right time and can be moved all the work they would otherwise carry out on the shop floor to the office environment. To complete the digital machine twin here, the third component is the physics simulation. It is based on NX Mechatronics Concept Designer and maps the physical behavior of the machine. In other words, all complex automation processes can be simulated here. I am now going to start the program on the left side via the control mode, so we can see what happens. The control moves, the signals go from the control model to the co-simulation. We see the sequences, the flap opens, the gripper grabs the tool, places it into the spindle, and the machine starts manufacturing. The signals then go back into the controller via the behavioral model. Thus we have a closed signal loop. This is what we professionally call software in the loop. It's all software-based, so to speak. We don't need any hardware for virtual commissioning. What advantages do we have? 100% availability. We don't have to wait for anyone to start the commissioning. We can take the machine twin with us anywhere. This makes any workplace an attractive workplace, even remotely. I can save a lot of waiting time by testing all my functions in advance. Of course, I also minimize the risk of collisions or expensive and time-consuming crashes. Moreover, it is possible to simulate errors. This means that a user can now try out what happens when the emergency stop is pushed. I'd like to demonstrate this. I'm pressing the emergency stop. We see that the machine is at a standstill. The appropriate notification is sent to our control system, so that we can be sure the program logic is working. Virtual commissioning shortens commissioning times, minimizes risks, and thus significantly reduces time to market.